Find maximum number of valid combinations for elements of two arrays. There are two n-length arrays, A and B. Consisting of integers is greater than 2. On every turn, I want to remove an integer from each array, A, I, and Bj, given that a certain condition about them is true, e.g. that they are not coprime. If the condition is not true, I'll try to remove another combination. After all, I want to find the maximum number of turns I can achieve this, until there is no possible combination to remove which meets the condition. Let's call this the optimum number of turns. I tried to solve this with a search algorithm and a priority queue using Python. Number underscore of underscore coprime underscore combinations, A, B, returns the number of possible coprime combinations given the arrays A and B. This is used as the cost of the given state of the two arrays. Not underscore coprime underscore combinations, A, B, returns a list of possible states, where a not coprime combination has been removed from A and B. The problem is that this solution is highly inefficient for large arrays of large integers. So I'm wondering if there is any better solution to this problem. Example: one could remove, which would lead to the optimum solution. But if one would remove, one would get to the suboptimal solution. The algorithm should always come up the optimum number of turns in this example 3.
Assuming function is underscore coprime underscore pair is defined, accepts a list of length 2 and returns true. For a pair of prime numbers, A and B are iterables to combine. Not underscore coprimes will hold all pairs that don't contain two prime numbers.
As far as I can tell, to solve this, construct bipartite graph G such that for each AI and Bj, if GCD AI Bj is greater than 1, there is an edge AI Bj in G. Find the maximum matching of G. Cardinality of the matching is the solution. I don't see how this could be solved faster.
I know where this problem you took. And your solution for this problem is wrong because it's O, N2, and greedy. N is lower than or equal to 10.5. 2 is greater than A, B is lower than 10.9 from array. I think in this problem you have to find some trick. And all algorithm for maximum matchings in bipartite graphs will TL.
If you want to support the channel, please consider liking and subscribing.